Hi, in this video we're going to look at how we go about making a formal inference on a population. We'll use the data sets that you're used to, so you'll recognize this one, rugby players' weight by position. At the start of the exercise, you will have posted a question about this. The question might look something like this. I wonder what the difference in median weight is between forwards and backs in the population of all forwards and back rugby players on the Rugby Sidestep Central website. That should be rugby, not Ruby, on the Rugby Sidestep website. Forget to put a question mark at the end of that sentence because it's a question. Now, linked to that, there's also the hypothesis, what you believe is going to happen. So the hypothesis might look something like this. Since forwards need to have more strength for scrummaging, and as backs need to be lighter so they can run quicker and with more agility, I hypothesize that the forwards will be heavier. So this is what you think is going to happen. Judged by what you're seeing on the diagram and by the research that you've done in the background, you hypothesize this is what might happen. Now you go and write up your analysis about these two sets of data. Once you finish the analysis, then you're going to make the formal inference. You're going to try and make some decision about the population. This is the key thing. We're talking about the population. We're going to make a call about the population based on this one sample that we've got here. This sample isn't the population. This is a sample. It's part of the population of rugby players that are listed on that website. Now, in order to do that, we're going to create a bootstrap confidence interval. And in order to do that, we're going to have to go to NZGrapher. So where is NZGrapher? It is over here. Let me just make this screen slightly bigger so we can see the whole thing. Right, so I'm going to choose my rugby set as usual. I'm going to go down to the bottom over here. And now instead of going to the dot plot, I'm going to go to this bootstrap confidence interval, median, because we're dealing with medians here. As before, we're going to choose the weight, and then we're going to choose the position. And here we get our confidence interval. I'll just shift this over. There's our original sample. And what they've done is they've resampled this 1,000 times. And we have this distribution down the bottom here of all those 1,000 samples. We can see on average that the forwards tend to be 18.5 kilograms heavier. And there's this confidence interval over here. That's the important thing that we're going to be looking at. And that's going to help us make a decision about the population based on this sample. So we go and put a proper title on it, and then we go and copy the picture. Picture has been copied. I go and paste it into the document. And I'm now going to start my write-up about what this bootstrapping confidence interval tells me. Firstly, I'm going to talk about the fact that there is an average distance. So by resampling my original sample 1,000 times, it would appear, and I use rather vague language here because I can't be 100% certain with these situations. It would appear that forwards seem to be on average 18.5 kilograms heavier than the backs. Okay, so there's my first statement. I've made a statement that on average the forwards appear to be heavier. Having done that, I'm then going to talk about this confidence interval over here. So you can paste in some statement, and the statement might look something like this. The bootstrapping confidence interval, that's this blue part over here, shows that in the 1,000 samples, we took 1,000 samples from here, 95% of the time, the forwards were between 16 and 23 kilograms heavier. So I'm listing the extremes of this confidence interval. So 95% of the time, 950 times out of that 1,000 samples, the forwards were between 16 and 23 kilograms heavier. Now, having got that down, I'm now going to refer back to that hypothesis that I gave a little bit earlier. as the limits of the confidence interval, so these numbers here, as the limits of the confidence interval are both positive, it would appear, again, I'm using rather vague language, it would appear that in the population of rugby players on the Rugby Side Central website, the forwards tend to be heavier than the backs. So I'm no longer talking about my sample now. I've said from this sample, I think that in the population of those rugby players, that the forwards tend to be heavier than the backs. I go and refer back to that hypothesis, that belief that I had at the beginning. This appears to support the hypothesis that I made at the start. It seems to be the case that in the population of rugby players on the Rugby Side Central website, the forwards are heavier than the backs. And there we have made a formal inference about the population of rugby players. Now, we've got a situation over here where this confidence interval is positive on both sides, positive 16 to positive 23. That means whenever I subtracted the sample medians, the forwards were always heavier than the backs. Okay, there were no situations where the backs ended up being heavier than the forwards. We're going to look at another example that shows that we won't always be 100% certain about that regard. So now we'll have a look at a different sample. So I'm still dealing with rugby players, but now instead of comparing by position, I'm going to compare by country, the South Africans and the New Zealand rugby players. And we can see from the box and whisker that the confidence interval around the medians is overlapping. And you'll remember from what we said earlier, at level 2, that means I can't make a call on this one. How do we use the inference to back up our decision? So here's the question. I wonder what the difference in weight is between New Zealand and South African rugby players in the population of all South African and New Zealand rugby players on the, rugby, on the Rugby Side Central website. Now, my hypothesis in this case was, given that among New Zealand rugby players, many players come from rural settings where they have to work hard on agricultural projects, I hypothesize that the New Zealanders will be heavier. Now, that is my belief. I think this is what's going to happen. I'm now going to test that hypothesis to see whether or not that's true. So I'm going to go and do a bootstrapping, going to create a bootstrap confidence interval to see whether that is true. So I'm going to move across to that. And here it is here. Let's move that graph in. So here's the bootstrap confidence interval for this particular data set. I'll move it over the side. And you'll notice now we've once again got a confidence interval. The average weight seems to be that the New Zealanders are heavier than the South Africans, but the confidence interval goes from a negative to a positive, and that has an implication. It means that sometimes the South Africans were heavier than the New Zealanders, other times the New Zealanders were heavier than the South Africans. So let's look at the write-up of these two. So commenting on this, I can say something like this. By resampling my original sample 1,000 times, it would appear that the New Zealanders seem to be on average 2.5 kilograms heavier than the, not backs, that's what happens when you cut and paste, than the South Africans. The bootstrapping confidence interval shows that in the 1,000 samples, 95% of the time the New Zealanders were heavier between -3 and 8.5. The New Zealanders were between -3 and 8.5 kilograms heavier. Now I need to explain what this -3 means. This means that sometimes the South African players were heavier by up to 3 kilograms, but then at other times the New Zealanders were heavier by up to 8 kilograms. So there I've gone and explained this confidence interval, what this -3 over here means. It means that the South Africans could have been heavier than the... Now I need to make some comment about that, explain what that confidence interval means. So I might have something like this. As the limits of the confidence interval range from negative to positive, it would appear that the population of New Zealand and South African rugby players in the website, that in the population of New Zealand and South African rugby players on the Rugby Sidestep Central website, the New Zealanders are not always heavier than the South African rugby players. Okay, that's the fact that we straddle 0 over there means that we can't always be sure that the New Zealanders are going to be heavier. And so I'll finish this off with one last statement, and that last statement will be this. Thus, the hypothesis that I made at the start cannot be justified by this investigation. Okay, sometimes that hypothesis you make will be wrong. I cannot determine with any level of certainty if the New Zealand rugby players will always be heavier than the South African rugby players in the population of these players on the Rugby Central website. Just because you make a hypothesis, it doesn't matter if that isn't shown to be true. You've gone and tested it, and the test has shown that it isn't necessarily true, and that's an answer in itself. So sometimes your conclusion over here will contradict the hypothesis that you made at the beginning, but that's fine. You've now got to a stage where you can make a decision. Now, what you're going to need to do is I have gone and given you these diagrams again. I've left a space over here in the middle for you to go and put your question hypothesis in here. And then next to it, I put the bootstrap confidence interval graph. And on the side of that over here, I would like you to go and write up a description of your bootstrapping confidence interval process, like I've done over here. I've given you 2 examples up over here. I'd like you to do the same thing for the Kiwi, for the car prices, for the marathon times, for the birth weights, and for the amount spent on ball. Okay, remember you're practicing this process of having to do a write-up. I hope that makes sense to you. What you need to now do is to go and do it. So good luck with that. I look forward to reading your submissions on your OneNote. Goodbye.